MasteRC pile caps. A very, very powerful little program. Here we got a little two pile cap. The column is eccentric from the beam, the pile cap. Obviously, most people would just design this as a simple beam, but doing it as a pile cap does have its advantages using truss analogies and the likes to get a more accurate design. If I was then to go and look at my second example, this is a 4-pile pile cap, and again the column is eccentric. I can then suddenly turn around and say, well, actually I want to create the imposed loading from wind or whatever gives me 120 kilonewton meter moment in both axes. And obviously that's not really going to worry this little very deep. So as I come down, you'll suddenly find I have problems with shear, and if you look at my results, I am looking at the moments and from that proportioning out where the ultimate loads are, and from that back calculating what the design moments were going to be from the summation of the pile loads times their distances from the surface. So it's calculating for each of these piles backwards and finding the worst moments in the MX and the MY to do the design. So it's a very smart and intelligent little program for doing pile caps, and it's very simple and easy to use. EC2, SABs, and the BS. So obviously the old-fashioned BS or the more up-to-date EC. We can also do square piles, so that if we have piles that are square, it'll allow a bit more on the edges to ensure that if the piles aren't set square, that they don't suddenly stick out. So it creates a circumscribed circle around the pile cap rather than inscribed. As you can see, so we get the same arrangement. And also, what else can we do? So let's looking at pile diameters, the working loads, the number of piles, and our loading. The loading as well, you need to understand when we're working with the Euro codes, we also have this accompanying imposed load. So if we were dealing with a dead plus live plus wind condition, we would have an accompanying imposed load that has a different load factor, such that if you wanted to say that the wind was giving us a 500, well, since it's possibly detrimental, you might actually want to put it in a 1.5 rather than 1.05 if it's giving us those. So you have all the facilities you want to. So putting in a physical load, you can see now the shear perimeter is unhappy, and it's giving us a warning on our shear perimeter. Due to the enhancement, we're at 1.33, 30% overstressing in our shear. So what do? Very simply, we can add more rebar in the right axis, which isn't always that beneficial, or we make the foundation deeper. As you can see, it goes up very, very quickly, because as you get your thicker pile cap, your perimeters have been pushed out, which makes them longer and obviously deeper at the same time, so you're getting a squared function on that increase in capacity. Again, these are very simply exported into DXF and scheduled. Somebody's asking, can you do this as a beam? Let's get back to that first example. Example 1. Example 1 is being designed as a beam. It's looking at strut and tie and beam theory, and it's checking for both of those. So what we need, because at the minute I believe possibly the design method is the maximum, whereas I can say no, let's go for a beam theory. and it's now turning around and saying that, well, actually the strut angle is too large for beam theory. So it's saying, no, 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 you should be, in this case, asking for strut and tie rather than beam theory. So it is, again, holding your hand. So if I go back to beam theory and I take this and I reduce, so we're not getting a beam theory warning, we're just getting our deep beam design. So although it's a beam, it's still a deep beam due to its span. So it is again checking it using the deep beam theories. The centers of the piles is determined as pile diameter. So if you said, let's make this a wider 5-pile pile cap, a 5 piles apart pile cap, which is quite large, then you might find that we're no longer worried about deep beam theory, just beam theory, and beam theory itself is going to still make you have far bigger reinforcement as you would expect for such a shallow and long structure. So yes, you can go for long pile caps, you can go for beams, but it will always hold your hand and tell you when it is not suitable for design. So if this was required, obviously what you would be looking at doing is putting in an awful lot more reinforcement and seeing if that improves it. So we're still, and it's not really the bending that's the problem, it is the shear. As you can see, if we went up to 40mm bars, we have no bending problem, but we still have this shear problem. We just don't have the shear plane for doing that. And it is a pile cap rather than a beam check, so it's not going to be looking at your side steel as links at this moment in time. So if that was the case, then I would go and do it as a physical beam rather than try and mess around and try and be overly smart with it in that respect. So